Hello everyone. Today we will study about the Brownian motion, both standard and the Brownian motion in general. Okay. So we are going to start with the standard Brownian motion. So let me select this pen and we are going to start now. So we are going to start with the standard Brownian motion, that is also known as Weiner process. Okay. It is also known as Weiner process and it is denoted by letter W with a subscript T, where T denotes the time. Here our T is greater than equals to 0, that is our time. Could be anything, it could be 0 or anything greater than 0. So what is WT? WT is a stochastic process. Okay, and we are going to study about the properties about the Weiner process. So first property of the Weiner process is that W of 0 is equals to 0. That is, at time 0 the value of the process is always 0. That is, the value always starts with 0. Okay, next property we have WT, that is the value of the process at time t, has continuous sample paths. What does it mean? Has continuous sample paths. So let me show this using a simple graph over here. Suppose this is on x-axis we have time and on y-axis we have the value of the Weiner process at time t. So as we have studied the first property, the value of the process at time 0 is always 0, and second we have studied that it has continuous sample paths. That is, if we draw the graph of it, there will be never any break at any point. It will be always continuous. Okay, next the third property of Weiner process is that for any time, okay, let's say we have a time s which is greater than equals to 0 and it is less than time t, the increment, that is the change in value over the time t and s. Okay, the change in value between the time t and s is going to be distributed as normally normally distributed with mean 0 and various with t minus s. Since it is a standard Brownian motion, we have mean is equals to 0 and variance, which is dependent upon the time interval, it is going to be t minus s. So this was the third property of our Weiner process. Now another property of Weiner process is that for any time, let's say 0 greater than equals to less than equals to t1, less than equals to t2, up to less than equals to time tn. We will take a numerical example, small numerical example over here. Suppose we have time intervals 0, 5, 10, 15, and let's say up to 25. So these are our time intervals, and we will have a Weiner process. We will have a value associated with each of the time point. Okay, let's say we will have the value of the process at time 0 as w0, at time 5 as w5, at time, let's say 20 second, it would be w20. All right, so these are the values. So the difference between the process at different points of time are independent of each other, and these all are random variables which are independent. So one question that might come in exam is that state the reason that why we cannot model the share prices using this standard Brownian motion. So we can give here the reason that since the increments are independent for a standard Brownian motion, we cannot use it for share prices. Why is it so? Because it is obvious that share price will be somewhat dependent upon the prices in the past. All right, but here we have the property of independent increments, that the future values are not dependent upon the values in the past. Therefore we cannot use a standard Brownian motion to model the share price. Okay, so this is the reason. You can state in the exam, and before we move forward, we should know about these two values, these two terms, like which are FTW and Markovian. So FTW is nothing but it shows that the history of the process up to and including the time t. FTW is nothing but it is the value, it is value that contains all the information of the process w up to and including the time t. Okay, and what is Markovian? Markovian means Markovian is a process name, and what is it is said to be a process to be Markovian, that if we know the latest value of the process, then we have all the sufficient information to determine the probability of future value of the process. So if it is so, then we can say that our process is a Markovian process. Okay, and knowing the historical values would not make any difference in the value it is going to take in future. That is what it value takes in the past would not, if even if we know, then it is not going to make any difference in the value or in the probability of the value that it is going to take in the future. Okay, so we have here wt as normal 0 comma t. So how it come over here, we will see. It is very simple. And as we have studied the first property that, sorry, it was third property, that Wt minus Ws follows normal 0 comma t minus s. All right, so here Wt minus W0 will follow normal 0 t minus 0, that is equals to t, and W0, it comes from the first property that W0 is equals to 0. Therefore Wt, that is the value of the process at time t, follows nothing but normal with mean 0 and variance of t. This comes from here. And next point is that the value of the process, probability that the value of process at time t is less than infinite, given that the time is not infinite, is equals to 1. Okay, the Weiner process, or let's say as a standard Brownian motion. So we will summarize all these properties using a simple graph. In a simple graph, we will try to summarize all these properties. On the x-axis we have time t, and on the y-axis we have the value of the process Wt. So from the first property we do have the value of the process at time 0 as 0, and it has continuous sample paths, that is there is no any breaks in the process, and at any point of time there is no any break in the process. So let's say this is our graph for the Weiner process, and it has independent increments. Let's say the value that it takes between these 2 point of time, it is independent of the value that it has taken in this time period. It is independent of this time period. And this was all about the properties of the standard Brownian motion. Next we will study about the covariance of the Weiner process, scaling of the Weiner process, time inversion of the Weiner process. So these are some another properties based upon these fundamental properties. These are some another properties and some important derivations from exam point of view, time inversion, Weiner process. So we will cover these all in a separate